10.2 we were doing. Okay. I have taken questions randomly from here. So today I'll be picking the questions which still I have not taken. Okay, so I am going to take question number 4 and 5 because still I have not taken this question. However, question number 6, question number 7, and question number 8 already I have explained. Question number 9 also I have explained. Question number 10, I need to check. 11 I have taken. 12 also I have taken. And yeah, 13 I have not taken. So 3 4 questions are left over here. Just a moment, I am sharing the screen. Meanwhile, if you want me to take any particular question, please let me know the number, I'll take it. Question number 4 says that prove that tangent drawn at the end of diameter of a circle are parallel. So you are having a circle. First of all, just a moment. No? Yeah. You are having a circle and tangent drawn at the end of the diameter. So you can draw a diameter anyway. Suppose you are drawing a diameter like this, passing through the center. Suppose AB is the diameter, which is okay, it must pass through the center only. That's why we are calling it diameter. So AB is the diameter over here. Now the question says that prove that tangent drawn at the end of diameter. Tangent drawn at the end of the diameter. End means the end point of the diameter. One of the end point of the diameter is A, another end point of the diameter is B. Tangent you have to draw at a point A, and tangent you have to draw at a point B. Question says prove that tangent drawn at the end of diameter of a circle are parallel. Now you have to show that these two lines are parallel with each other. You can name it. You can say this is a line, straight line XY, and that is a straight line PQ. You have to prove that XY and PQ are parallel with each other. Okay, let's see how can we prove that these two are parallel with each other. XY is parallel to PQ. That's what we have to show over here. So since A is the point of contact because XY is the tangent and B is the point of contact because PQ is the tangent, do we know that tangent at any point of the circle, tangent at any point, it's perpendicular to the radius, okay, which passes through the point of contact. In this circle, so many radii we can draw like this, like this, like this. But the radius which is passing through this point of contact, this point of contact, that is a special radius which must be making 90 degree over here, right? Right?
Yes,
Yeah,
ma'am.
that's true.
Everyone, you know this theorem, right? Salva, you know this theorem, theorem number 1. Uh, Amir, you know this
Yes,
theorem,
ma'am.
right? And yeah, Farhan, you know this theorem, right?
Yes, ma'am.
Okay, so
Yes,
we will
ma'am.
declare that here 90 degree we are having. Similarly over there, because that PQ is also the tangent. So there also will be having 90 degree. Okay, this 90. Or maybe the other part will also be 90. Okay, now you use any property in lines and angles chapter you have done in your previous class. Lines and angles chapter. So from there, I am telling you, you use any property. Okay, either you say this two green color angle are 90 90, that means these two lines must be parallel. Why? Because xy and PQ you are having, and there is a transversal like this. If this angle and this angle added together is 180-degree, that means XY and PQ must be parallel, because these two are nothing but just the pair of co-interior angle, or interior angle on the same side of transversal, right? Or
Yes.
you say that one of the green angle this 90 and the other one is 90, this is nothing but just the alternate interior angle. You are having two line, very random line, okay, we don't know parallel not parallel, nothing we know, we are having just two random line, okay, and there is a transversal like this. If this angle is 90 and this is also 90, it looks like pair of alternate interior angle. And if these two are same, then the lines must be parallel with each other, right? Right?
Yes, ma'am.
Yes. Is it making sense? Farhan, are you getting it?
Yes, ma'am.
Selva, are you getting it? Are you there, Selva? Amir, are
Yes,
you
ma'am.
getting
Yes, ma'am.
it? Okay, now we just need to write it properly. We understood. If you are not getting, please let me know. I will explain it in detail that why we are taking alternate. If alternate interior angle are same, then the lines must be parallel line pair. Okay. So here we will say that just the figure is enough. We don't need to give that much explanation regarding the figure. We will just say that we know XY and PQ are two tangent such that here angle, I'm talking about this 90-degree YAB, okay, is equals to 90-degree. Here you need to write the theorem number one. Tangent at any point is tangent at any point of the circle is perpendicular to the radius through the point of contact. Similarly, that angle will also be 90-degree. I'm talking about angle PBA. That will also be 90-degree. Again, you don't have to write the same theorem. Okay. Therefore, angle YAB is equals to angle PBA. Here, XY and PQ are two lines and AB is transversal. And these two are nothing but pair of alternate interior angle. Okay, downside I'll write pair of alternate interior, and pair of alternate interior angles are equal. Write it, okay? Angles are equal. Therefore, hence, this XY must be parallel to PQ. And we are done with the proof. Okay, we were supposed to prove that tangent drawn at the end of diameter of a circle are parallel. So we have already proved tangent are parallel. Before starting the solution, we could have written that we have to show over there that XY is parallel to PQ. Okay. Anyone having any confusion over here?
Oh, no, ma'am.
Please note down the solution. I'll take the next one, number 5. Are you done, everyone?
Yes, ma'am, I'm done.
Yes. Salwa, are you done? Farhan, are you done? Ritvika, are you done?
Oh, yes, ma'am.
Yes, Farhan and Salwa.
Yes, ma'am. Done, ma'am.
Salwa, are you done?
Yes, ma'am.
Okay, let me take the next one. Question number 5, which says that prove that the perpendicular at a point of contact. Point of contact means there must be a tangent. There must be a tangent like this. Okay, we have to prove that perpendicular at a point of contact to the tangent. Now on this point of contact, suppose this is P. The point of contact, it's P. Okay. Now we have to show that perpendicular at the point of contact to the tangent to a circle passes through the center. Okay, perpendicular, this perpendicular, we have to show that it is passing through the center. We are just dropping, we are just having a circle, we are having the tangent, and this is the point of contact. At this point of contact, I am drawing a perpendicular. But then I am realizing that when I'm extending this line, going and going and going and going, it is passing through the center. That's what we have to show. Making sense?
Yes, ma'am.
Yes, ma'am.
Okay. You are having a tangent. Anywhere you are having a tangent, and at a point of contact, you are just dropping a perpendicular. But later on, you are finding that when this line you are stretching, it is just passing through the center of the circle. Okay. That's what you have to prove over here. If you will tell me that, yeah, we already know that there is theorem number 1, which says that, okay, tangent at any point of the circle is perpendicular to the radius through the point of contact, and it is the same thing. This theorem, this question number 5 is telling us the same thing what the first theorem says. Yes or no? That in a circle you can draw tangent at any point, any point you can draw tangent at any point. And this tangent, okay, this circle will have so many radius. But there is one special radius which will pass through the point of contact, which will touch the point of contact. So this is the special radius. Now this special radius must be perpendicular to the tangent. Yes or no? Right? Theorem number
Yes, ma'am.
1 says tangent at any point is perpendicular to the radius. Okay, the
Yes, ma'am.
radius which passes through the point of contact. So this one and this one is the same thing. How we will prove it? Are we going to just say that we know one theorem, theorem number 1, which says the same thing, and we are done with the proof? Am I going to say that according to theorem number 1, whatever is given in the question, and theorem number 1 also says the same thing, hence we are done with the proof? No. Even no, even though you know already that it is okay, it is obvious. Okay, we know this theorem. In theorem number 1 we have learned the same thing, and the same theorem we are using in almost all the questions. We know it. Okay, and I cannot just say for this particular question, when it says prove that, then I cannot say we know it. Anyhow, we have to prove it. Making sense?
Yes, ma'am.
Okay, so if you know even already the same thing, it's so just the basic statement is given, and you are thinking that this is really simple. Yes, it is simple, but anyhow you have to give a proper reasoning to prove it. Even though you know it, you have to prove it. Okay, by giving any condition or any reasoning. So what we will say that just a moment, no? Let me check what can be the easiest way to approach. Just a moment, I am coming to the explanation. Yeah, this approach will help. Okay, let me explain what I am trying to do over here. So first of all, we will draw a circle. According to this theorem, it says that prove that perpendicular at a point of contact. So on this point of contact, that is P, I am dropping a perpendicular. Okay, that is just, I am trying to draw it a little bit this way. Even though it doesn't look like perpendicular, please believe it that it is perpendicular only. Okay, so I'm drawing a perpendicular at this point of contact, that is xp, and I have to just prove that this xp must be passing through the center of the circle. Clear?
Yes, ma'am.
Okay, so I will first of all, I'm going to say that we know it is given over here. Okay, it is given over here that xp is a line which is perpendicular to the this tangent, which is AB. It is given over here that it is perpendicular to AB. Clear so far? XP is a line, like we have just dropped the perpendicular at the point of contact P, and that is XP. Don't worry about the figure, why the line is looking like this, tilted and slant. Don't worry about that. Just take it that this is parallel, making, this is perpendicular. Making sense?
Yes, ma'am.
Okay, if you are not understanding why we are taking it, then read the statement. Prove that the perpendicular at the point of contact. What I have taken? Perpendicular at the point of contact. Just that. I have taken perpendicular at the point of contact. Okay, of this tangent, perpendicular I have taken of this point of contact. Okay, to this point of contact, I have taken the perpendicular, that is xp. Okay, it is given in the question. Now we will say that, but we know one theorem. We know one theorem which says that OP will also be perpendicular. Making sense? We know a theorem which says that OP is also perpendicular to this tangent AB. Making sense? That tangent at any point is perpendicular to the radius. OP is the radius through the point of contact. Clear?
Yes, ma'am.
Okay, now it is not possible that you will draw a perpendicular to the same line, same point. Same point. You are drawing two perpendiculars, one like this and one like this. Okay, and those two are different line segments. It's not possible at all. Hence, these two are same line segment, or maybe we will say this XP must be passing through O. Clear?
Yes, ma'am.
Is it making sense to all of you? Are you getting it? Yes.
Yes, ma'am.
Farhan, are you getting?
Yes, ma'am.
Salwa, are you getting? Okay, everyone is getting. Let's proceed. So I am saying XP is perpendicular to AB. That is given over here. Given. But we know that this OP is perpendicular to AB. And here we'll write the reason why. Tangent at any point is perpendicular to the radius through the point of contact. Okay, now we will say this is not possible. If these two are different line segments, then this is not possible that at P only we are having two perpendicular lines. Okay, so it is not possible to get two different perpendiculars at P. Okay, hence XP must be passing through the center of the circle, that is O. Hence XP must be passing through O. That's what we wanted to prove. Read the theorem. Prove that perpendicular at the point of contact to the tangent to a circle passes through the center. And now we are done with the proof. Can you say it?
Yes, ma'am.
Okay, so yeah, this is how we'll be proving it. We are having the circle, we are having the tangent. Yes, Abdullah, just now you have joined. We are doing question number 5. Here it says that prove that perpendicular at a point of contact to the tangent to a circle passes through the center. That means if you are having a circle and if you are having the tangent, then if you are dropping the perpendicular at this point of contact, a perpendicular, then you have to prove that this perpendicular must be passing through the center of the circle. Okay, so what you are doing, you are drawing it a little bit like this. Even though it doesn't looks like perpendicular, it's completely okay to draw it like this. And we are saying that, let's say xp is perpendicular to this tangent AB. Okay, and there is a theorem which says that OP is also perpendicular to AB. Okay, this two condition giving us the conclusion that this XP must be passing through OP. Why? Because at the same point, two different perpendiculars are not possible. Making sense?
Yes, ma'am.
Yes,
Yes.
Abdullah, are you understanding?
Yes.
Okay, and this is the complete proof which is there on this screen. Yes, everyone, please note it down. I'll take the last question. Figure, explanation, and the proof, everything is there on the screen. If anywhere anything is not that clear, please let me know. I'll explain it again. And yeah, let me know once you are done. Are you done? Are
One
you
second.
done,
Yes.
everyone? Okay, now let me take the remaining questions. Just a moment. I'll be taking question number 13. Okay, and if you want, I can also take question number 12, which is the most calculative question. Okay, so many steps are involved for 12 as well. So after 13, I can take 12 as well. Let's finish this 13 first. Prove that opposite side of a quadrilateral circumscribing a circle. Now, you always ask me what is the meaning of circumscribing a circle, a quadrilateral circumscribing a circle. So a quadrilateral circumscribing a circle means you are having a quadrilateral and your circle is touching all these four sides of this quadrilateral. Your circle must touch AB, must touch BC, must touch this CD and DA as well. Touching means, okay, it must behave, this AB will start behaving like a tangent to this circle. Similarly, AD will work like a tangent to the circle, CD will work like a tangent to the circle, okay, and this BC will also work like a tangent to the circle. This is the meaning that quadrilateral is circumscribing a circle. Making sense?
Yes, ma'am.
We have to prove over here that prove that opposite side of a quadrilateral. Opposite side of a quadrilateral, here opposite sides are AB and CD, and AD and BC, these two are opposite sides here. So you have to prove that opposite side of a quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. That means opposite side subtend supplementary angle at the center. Okay, I mean this AB side is making angle at the center. How side makes angle at the center? This is how side AB will make angle at the center. Okay, ये जो साइड ए बी है ये सेंटर पे एंगल कैसे क्रिएट करेगा, तो हम ये जो एंड पॉइंट ए है उसे सेंटर से ज्वाइन करेंगे और ये जो एंड पॉइंट बी है उसे सेंटर से ज्वाइन करेंगे, तो ये जो एंगल क्रिएट हो रहा है हम कह सकते हैं दैट दिस एंगल इज क्रिएटेड बाय द साइड ए बी. सर्कल में अगर अगर हमारे पास एक सर्कल है और मैंने कहीं एक कॉर्ड कॉर्ड ड्रॉ कर दिया, लेट्स से कॉर्ड पी क्यू ड्रॉ किया. अब अगर क्वेश्चन में बोला जा रहा है कॉर्ड पी क्यू इज मेकिंग एंगल एट द सेंटर, इसका मतलब क्या है? इसका मतलब ये है कि ये जो एंड पॉइंट P है ये सेंटर से ज्वाइन है और ये जो एंड पॉइंट Q है ये सेंटर से ज्वाइंड है, और ये जो एंगल क्रिएट हो रहा है इसे हम कह सकते हैं कि ये जो कॉर्ड PQ है ना ये एंगल बना रहा है, दैट इज एंगल POQ एट द सेंटर ऑफ द सर्कल. मेकिंग सेंस? we can say chord PQ is making angle at the center of the circle. और जहां हम हमारे सिचुएशन में हमें बोला जा रहा है कि एक साइड है, क्वाड्रिलेटरल का एक ऐसा साइड है जो सेंटर पे एंगल क्रिएट कर रहा है. तो साइड कैसे सेंटर पे एंगल क्रिएट कर सकता है? तो वन ऑफ द एंड पॉइंट यू विल ज्वाइन विद द सेंटर, अनदर एंड पॉइंट यू विल ज्वाइन विद द सेंटर. और अब हम कह सकते हैं कि ये जो एंगल क्रिएट हो रहा है ना ये साइड ए बी बना रहा है कहाँ? सेंटर के ऊपर. आ रहा है समझ में?
Yes, ma'am.
Okay. Similarly, side CD will also make angle at the center. What does that mean? That means exactly the same thing, that the end point D we will join with the center and the end point C we will join with the center. And this angle which is getting created, this is called as a side CD is making angle at the center. Clear?
Yes, ma'am.
Okay, so in this question, first of all, it says that prove that opposite side of a quadrilateral. Then he started giving the declaration about the quadrilateral, that you are having such a quadrilateral which is circumscribing a circle. Now it is repeating that what exactly is happening over here. So you have to only read this part, that prove that opposite side of a quadrilateral subtend supplementary angle at the center of the circle. Don't read this in between part, circumscribing a circle, क्योंकि वो just justify कर रहा है कि हमारा quadrilateral कैसा है. ओके तो हमें क्या प्रूव करके दिखाना है? ऑपोजिट साइड ऑफ अ क्वाड्रिलेटरल सबटेंड सप्लीमेंट्री एंगल एट द सेंटर. ओके, एक क्वाड्रिलेटरल है जिसके ऑपोजिट साइड ये जो एंगल क्रिएट कर रहा है, ये दिस अपोजिट साइड एंड द अनदर अपोजिट साइड इज क्रिएटिंग दिस एंगल. आई मीन दिस एंगल एंड दिस एंगल. These two are supplementary with each other. What does that mean? Supplementary means both added together must be 180-degree. Are you understanding?
Yes, ma'am.
Yes, ma'am.
Okay, these two angle are supplementary with each other. We have to show over here that this two angle which is getting created by the opposite side, together they are supplementary with each other. Not only these two are supplementary. Okay, this angle 1 and angle 2, these two are also supplementary with each other. But in such question, we don't prove both the cases. We prove any one of them, either this one or maybe this one, and the other one we say similarly, the other one can also be proved, right? So we have to
Yes.
focus either on this one or maybe we will be proving the other one. Any one we have to prove that both the opposite sides together, they are creating angle at the center, and these two angle are not random angle. These two angle are supplementary with each other. That means added together is 180. What the statement says, is that making sense to all of you?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
let's see what can be done over here. I'm going to take that first of all you need to understand what the question says. If you are not clear with the statement, then you will end up telling me that all question looks same to you. You are not able to understand that how to start, because like any theorems proof you are seeing in the notebook and you are understanding the proof, but still you are not able to understand how to approach the question by yourself, because you are not understanding what the question says. Here what the question says, that it is, you have to show that angle AOB plus angle COD, it's equals to 180. In each and every question, when you are facing this challenge, no, in any of the chapter, just open your book and in each and every question just try figuring it out, what is given and what you have to find. Just that, you don't have to solve the question, just see what is given and what you have to find. Just that, if you are able to understand this too, that means the next approach is to learn how we are proceeding, what approach we are taking. Okay, now here either we will be proving this one or maybe we will be proving that angle AOD plus angle BOC, these two added together, it's 180-degree. And what is given over here? What data is given over here? So here it is given that just ABCD is a random quadrilateral which is circumscribing the circle. This quadrilateral is circumscribing the circle. This case is really important. Okay, so we will be writing ABCD quadrilateral, ABCD is circumscribing a circle. Just that is given, nothing else. Okay, no radius, nothing. Is it clear so far? Just the given part and the showing part.
Yes, ma'am.
If this much is clear, then we can focus on the approach. Now we will think how to prove this two are, okay, this two added together is 180. So see, it's, you will be able to understand what to do over only two theorems you have learned in class 10. Okay, the first one is the tangent is perpendicular to the radius passing through the point of contact, or the other one is external point theorem, that from an external point maximum two tangent can be drawn, but this two tangent must be equal in length. Okay, that theorem you have learned, so the same theorem we'll be using over here. We will say that this A, okay, this A, I think I need to take another color. We will say that this A looks like external point, which this concept we have used in so many questions. Every time circumscribing based question, you have used this property. So if I will tell you that this, let me take it P, Q, R, S. If I will tell you that AP and AS are equal in length, you will not tell me that no, 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 it's not equal, right?
Yes, ma'am.
From external point theorem. Similarly, BP-BQ same in length. Similarly, CQ-CR same in length. And similarly, DS and DR are equal in length. Okay, so these many informations we are already having. Now what can be done? What we can do over here, we can join, we can drop the perpendicular. Okay, radius I am drawing. The special radius which will be perpendicular to the point of contact, that radius I am drawing. Okay, at P, the same I am doing for Q, the same I am doing for R, and the same I am doing for S. Okay, now if you will take this two triangle, any two triangle, I am talking about triangle. This, okay, O is the center. This triangle APO and the triangle. Can you see the black color triangle and the blue color triangle? The black one and the blue one. Can you see that?
Yes, ma'am.
Okay, I'll take this triangle APO and triangle ASO. And easily we will be able to say these two are congruent. Now, if you are thinking whatever we have to proof, what is the relation with congruency and all? So let me tell you why we are taking this congruency. Okay, easily you will be able to prove this APO triangle and ASO triangle are congruent with each other. I am coming with the step. Easily you will be able to prove. Similarly, this triangle, this DSO, wait, this DSO and DOR will also be congruent with each other. I mean, I'm talking about this triangle and this triangle, the green one and the yellow one, these two are also congruent with each other. Okay, you will be able to prove. I am coming to that how you will be able to prove these two are congruent. Similarly, all this triangle, okay, similarly you will find that here also you are having a triangle and here also you are having a triangle which will be congruent with each other. And similarly you will realize that here also you are having a triangle and here also you are having a triangle which are congruent with each other. Okay, easily you will be able to prove that this set of triangles are congruent with each other. The moment you will prove these are congruent, all of them you don't have to prove congruent. Only one you will be proving congruent, and you will say similarly all will be congruent with each other. Okay, and the moment you will be able to prove these are congruent, now let me draw the actual figure, what how it is going to help us. First try to understand the steps which we'll be following, and then you can note it down. So we were having a circle. Okay, quadrilateral was there which was circumscribing this circle, and we wanted to prove that this AB and CD, whatever angle it is creating at the center of the circle, these two are supplementary with each other. Similarly, the angle created by Similarly, angle created by this AD and BC are supplementary with each other. Now, the moment you will be able to prove that these triangles are congruent, then you will be able to say that this angle and this angle will be same. Making sense? After congruency by CPCT, you will be able to say. Okay, similarly, after congruency by CPCT, you will be able to say that this two angle will be same. This two angle will be same. Okay, how you will prove the congruent and all, I am coming to that, but focus on after congruency how it is going to help us for doing the proof whatever we want. So first of all, you are just joining the radius. Okay, all those radius which is making 90-degree at the point of contact, you have joined. Okay, then tangent external point theorem and this 90-degree, these two are enough to help you proving the congruency. The moment you are proving these two triangle are congruent, automatically you know that in congruent triangle, corresponding part of the congruent triangle will be same. So in case you are proving that this triangle APO and ASO are congruent, of course angle O over here and angle O over here must be same, right? Angle O over here and angle O over here, if that is X, this will also be X. Making sense?
Yes, ma'am.
Okay, and same way angle 2 will also be same way angle 3 will also be same, and same way angle 4 will also be same. I mean, जैसे हमने प्रूफ करके जैसे हम दिखाएंगे एपीओ और एएसओ आपस में कन्ग्रुएंट है, जस्ट इस स्टेप के बाद हम बोलने वाले हैं कि हमारे ऐसे दो दो पेयर, ऐसे बहुत सारे, ओके, एक यहाँ से ये दोनों ट्रायंगल आपस में कन्ग्रुएंट होंगे। सिमिलरली जस्ट हमें सिमिलरली लिख के और जस्ट डिक्लेयर करना होगा कि ये दोनों ट्रायंगल भी आपस में कन्ग्रुएंट होंगे और ये दोनों ट्रायंगल भी आपस में कन्ग्रुएंट होंगे। जिस तरीके से एपीओ और एएसओ आपस में कन्ग्रुएंट है, उसी तरीके से ऐसे बहुत सारे ट्रायंगल मिलेंगे जो आपस में कन्ग्रुएंट होंगे, क्योंकि सबके पास एक्सटर्नल पॉइंट थ्योरम की हेल्प से हम लेंथ सेम बता पाएंगे 90 डिग्री। ओके, इन सारे ट्रायंगल्स में हमारे पास 90 डिग्री होगा। आई विल शो यू। ओके, इस तरीके से हमारे ये सारे पेयर्स आपस में कन्ग्रुएंट होंगे। और जैसे ही हमने ये डिक्लेयर किया कि ये सारे पेयर्स आपस में कन्ग्रुएंट है, अब हम कह सकते हैं कि ये जो कंप्लीट एंगल सर्कल में तो 360 डिग्री का होता है, यस और नो? सर्कल में ये पूरा अगर एक रिवोल्यूशन हम ऐसे कंप्लीट कर ले तो इसे तो कंप्लीट एंगल कहते हैं, विच इज 360 डिग्री, यस और नो? राइट? तो ये जो completely angle है, I am talking about this angle. If you are wondering which angle, so I am talking about this bold black colored angle. Can you see all together is 360 degree? Yes or no?
Yes, ma'am.
Yes.
Okay, if all together is 360 degree, we are almost there. Okay, we are almost there. Now you will say angle 1 plus angle 1 plus angle 2 plus angle 2 plus angle 3 plus angle 3 plus angle 4 plus angle 4, ऑल टुगेदर इज 360 डिग्री। और यहां से हमें क्या मिलने वाला है? 2 टाइम्स एंगल 1 प्लस 2 टाइम्स एंगल 2 प्लस 2 टाइम्स एंगल 3 प्लस 2 टाइम्स एंगल 4, ऑल टुगेदर इज 360 डिग्री। और अगर हमने 2 कॉमन ले लिया लेफ्ट हैंड साइड से, 2 कॉमन ले लिया तो हमें मिलेगा एंगल 1 प्लस एंगल 2 प्लस एंगल 3 प्लस एंगल 4, दैट इज 360 डिग्री। 2 we will be shifting to the other side. Pair of linear equation you all have done. So if I'm shifting 2 to the other side, you will not ask me why I'm doing so. So angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 360 by 2. 360 by 2, that means 180 degree. We are done. If you are thinking how, so please check. Okay, this AOB in the actual figure, please check this AOB. Can you see this AOB completely? It's angle 1 plus angle 4. Can you see that in this triangle AOB? AOB. Can you see a teeny tiny part where I have written angle 1 and a teeny tiny part where I have written angle 4? Can you see
Yes,
that?
ma'am.
Yes or no? Okay,
Mm.
and the other triangle, that is COD. I'm coming to that. Can you see this COD triangle as well? Where the teeny tiny part I have written here angle 2 and a teeny tiny part I have written angle 3. तो अगर हमें अभी अभी हमारे पास क्या है, एंगल 1 2 3 4 सारे मिला के 180 बना रहे हैं, क्या हम लिख सकते हैं कि एंगल 1 प्लस 2 प्लस 3 प्लस 4, इसका मतलब है एंगल 1 एंड 4 को एक साथ लिख के हम इसे AOB एंगल बुला सकते हैं, और एंगल 2 एंड 3 को एक साथ लिख के हम इसे सीओडी एंगल सीओडी बुला सकते हैं। आ रहा है समझ में? और यहाँ से ऑलरेडी 180 डिग्री हमारे पास है दूसरे साइड में, तो इसका मतलब है हमने प्रूफ कर दिखाया। इज इट मेकिंग सेंस?
Yes, ma'am.
This is how we'll be approaching this question. Okay, today I'll not give you the solution. I will explain it one more time, okay, before wrapping up this class. So I'm erasing everything from here, and here we are supposed to prove AOB, like you are having a quadrilateral. You are having a circle which is circumscribing it, and you have to prove that opposite sides, A, B, C, D, opposite sides are making angle at the center, but these two angle are not these two angle are not random angle. These two are supplementary with each other. So what you are doing, you are just joining the point of contact, you are joining the point of contact, you are joining the point of contact, you are joining the point of contact. Easily you will be able to prove this is P, this is Q, this is R, this is S. Easily you will be able to prove that this triangle APO and ASO are congruent with each other. Easily. I'll show you in the next class how. The moment you will be able to prove these two are congruent, that means corresponding angle will be equal with each other. So this is angle 1 and this is angle 1. The angles will be same. By CPCT you used to write in the previous class. The same thing we are using over here. Here again we will say that similarly this two triangle will also be congruent. So angle over here and angle over here must be equal. So this is angle 2 and this is again angle 2. Similarly we have two more pairs. This is angle 3 and this will also be angle 3. Due to congruency I am saying, okay, illogically, baselessly, we are not declaring that these two angles are same. I'll show you how congruency work. And similarly we are saying this is angle 4. Wait, we are saying this is angle 4 and this is angle 4. Now we are saying that all this angle added together must be 360 degree, a complete angle in a circle. So angle 1, angle 1, angle 2, angle 2, angle 3, angle 3, okay, angle 4, angle 4. Actually I'm adding, so that's why I'm not careful with the sequence. Okay, I'm randomly just adding all of them, and all together is 360 degree complete angle. Okay, and from here we are getting angle 1 plus angle 2 plus angle 3 plus angle 4, that is 180 degree. And from just after this step I am telling you we are done with the proof. Okay, if you are wondering how, so told you that please focus angle 1 and angle 3 you are having together, which is nothing but this angle AOB. Making sense?